Hello students, today we are going to focus on the hydrolysis and hydration. What is the difference between the two terms? Where can we see the major difference in these two? Here you see, first if you take hydrolysis, you people are know hydro means water, lysis means breaking down. Okay, so I am taking one compound, I am mixing with water. Whenever you mix these two, okay, together, two compounds get breakdown. Have you got it? That means compound will break down and as well as water also get break down into H plus and OH minus. So that is called as hydrolysis. Okay. So whereas coming to the hydration, in the hydration, the compound if you mix with water, compound may involve in the dissociation or may not involve in the dissociation. But water never involve in the dissociation. It will be as it is. Okay, so I think you may get one doubt here. Sir, what type of interaction existing between the compound and water molecule in hydration? There are three types of interactions. One is ion dipole interaction and hydrogen bond interaction, and next one coordinate covalent bond interaction in the hydration. Here you must remember one point. In hydrolysis, here the water will dissociate into H plus and OH minus, hydrolysis. But hydration, that water molecule never get dissociate into H plus and OH minus. This is major difference. Whereas coming to the hydrolysis, here I told you already, compound and water both get dissociated. That's why it is called double decomposition reaction. Hydrolysis is a double decomposition reaction. Have you got it or not? Here you see, if you see one or two examples, you will get full clarity about this concept. You see these two examples. Hydrolysis of salt I am taking here. Here CH3COO NH4. Here this salt is a salt of weak acid and weak base. So if you add to the water, both salt as well as water get decomposed and forms related compounds like acetic acid and ammonium hydroxide. Here you should remember one important point. All salts may not involve in the hydrolysis. Sir, which are not involving in the hydrolysis? Can you tell, sir? Salt of strong acid and strong base are not at all involving in the hydrolysis. Keep it in your mind. One more example. I think you may get one doubt. Sir, here salts means what? They are ionic compounds. What about covalent compounds? You see some covalent compounds also involving in the hydrolysis, that is BCl3. If you take BCl3 mixed with water, they are converting into BOH taken thrice. Okay, it will be converted into taken thrice. Right? Here also you observe an important point. Here compound, the added compound as well as water both get dissociated. Is it clear? Now we go to the hydration example. Hydration of NaCl. I am adding that NaCl into the water. Here, whenever you add NaCl into the water, NaCl is involving in the hydration, not hydrolysis. Here, I already told you, hydration means here water molecule never get dissociated. You see here, NaCl whenever you add to the water, it converted into Na plus and Cl minus. Na plus is surrounded by the water molecules. Okay, so and both are having one interaction. That interaction is called as ion dipole interaction. Have you got it what I am talking here? Same manner, you see water is a dipole. Na plus is a ion. Ion dipole interactions exist. Water did not dissociate. Here whereas coming to the Cl minus negative charge. It is surrounded by what? Positive charged hydrogens. Here one example. I'll take one more example which we know very well in the complex compounds. Copper sulfate actually. Copper sulfate anhydrous is a colorless. When you add water to that, it will become as like a blue color complex. Here in that complex CuSO4 5H2O. These 5 water molecules are having coordinate covalent bond with CuSO4. Majorly Cu. Okay, here water is never get dissociated. So that is the major difference, students. You can